Alright, in our final installment of Reinforcement Learning for Dummies, we are going to be looking at correlated Q learning and Greenwald and Hall's experimentation. First, we'll start with the soccer environment. This was modeled with this code right here, basically keeping track of the state, modeling movement, and then implementing the logic for what happens when you hit a wall, collide, or hit the goal state. So that's all modeled with just this right here. Using that environment, we ran the 4 learning agents against it over 1,000,000 steps each, and then observed a particular player's Q value differences when they're in a particular state and a particular set of joint actions happened. And that's all outlined here. After each game, the state was reset also to this current state here, and that allowed us to visit the observation state action pair more often to be able to get more data points. This wasn't specified in the paper, but it made sense in implementation, and it worked well for the experiments that were run. Alright, so the agents all use the discount factor gamma of 0.9. This is specified in the paper, and then they each brought their own value function. The Q learner only kept track of individual players' view of the world, so their Q tables only tracked their set of actions in a given state. Value function is just basically the max of those Q values across that particular player's set of actions. Q learning used the initial alpha of 0.3 and was decayed exponentially with this decay factor. This is inspired by Littman's friend-foe paper, and experimentation happened on using different schedules and different initial alphas to try to mimic the rate of convergence seen in the experimentation. These are not given in the original paper. All that's given is that there's a minimum value and that there is some decay schedule that's not specified. There's also decay of epsilon for the Q learner, which is the only on-policy learner. Everything else uses random actions, so they didn't need an epsilon. So the other agents besides Q all started at an alpha of 1, and then friend Q was the only diverging schedule, alpha decay schedule. It actually used the one specified in Greenwald's updated paper. This worked out the best to illustrate the convergence of friend Q. Alright, faux Q value update function. This is basically minimax. The essence of the constraints being modeled are right here, saying that we're maximizing this value parameter by distributing over all of our possible actions based on actions taken, adversarial actions taken by the other player. Friend Q is simply the max Q value over the joint action state or action space, and then CEQ is basically modeling the rationality constraints, saying that players should take that any player's action is at least as good as any other action given what the other players are given that the other players are following the recommended action. So this is all modeled in these rationality constraints, and they also have the probability constraints tied to them. So this is summed up with this right here, saying this is basically the constraints modeled in the linear program. Alright, so the results of all of this, the plots are very close to identical to Greenwald and Hall's original graphs. The only discrepancy is likely due to the decay schedule of alpha and initial alphas. Correlated Q and faux Q both had identical values and convergence rates. You can see these are identical, same result that was in the original paper. Friend Q, in the same way, reached convergence very quickly, and then Q learner never converged, and it only went down as much as the learning rate. And that is it. Thank you.